Hello, today we are going to look at what types of chemical reactions exist. Today we will talk about the main types of chemical reactions that exist in chemistry, and later we will find out how chemical reactions are further divided. So there are four main types of chemical reactions. The first of these reactions is called compounding, or it is sometimes called synthesis. The second reaction is called decomposition, or it is sometimes called analysis. The third reaction is called substitution, or sometimes simple substitution is added, and accordingly there is also double substitution, which can be called exchange. So to begin with, let us remind you that each chemical reaction has a certain scheme, which will allow you to easily find such a chemical reaction among others. So, the scheme for a coupling reaction can be written like this. Well, for example, A plus B equals AB. Or maybe it's more complicated than that. Let's say A plus BC equals ABC. Recognize this chemical reaction on the right side, where there is always only one and necessarily complex substance. But on the left side, it can be both simple and complex substances, participants of this process. And let us give examples of such a reaction, the reaction of a compound, to prove it. For example, let's say it's the interaction of phosphorus and oxygen. This reaction results in phosphorus oxide, where oxygen has an oxidation degree of -2 and phosphorus has an oxidation degree of +5. Then the formula would be P2O5. Next, let's equate. Here we'll use the least common multiple method. Here we have 2 oxygen, here we have 5. Then here we'll put 5, here we'll put 2, and to phosphorus we'll put 4. And let's give an example of a slightly more complex reaction that can take place. For example, HO gas can also react with oxygen to form H2O. Now let's equate, but here we can't use common multiples because oxygen is divided. Then let's remind, there is a rule where there is an odd multiple, and the odd multiple is exactly in HO. It is necessary to put an even multiple, i.e. to make an even multiple from the odd one. Let's put 2 here. Then 2 should be put here as well, and by oxygen check. Here it is 4, on the right it is 4. It's true that this reaction is reversible. This is one of the, by the way, additional classifications of chemical reactions. The next reaction is decomposition. This reaction is the reverse of the coupling reaction. And then AB, conventionally, a substance can decompose into A plus B, or for example, the substance A, B, and C decomposes into A, let's say, plus B. Basic. So, by this reaction, we reverse each other from compounding and decomposition. But let us give an example of such a reaction which plays a very important role in the decomposition of water. It is true that in order for the decomposition reaction to be possible, it must be heated, for example, or an electric current must be passed through. Water decomposes into hydrogen gas and oxygen gas. Let's equate the two. Here we have 1 oxygen, on the right we have 2. We'll put 2 in front of the water formula, and accordingly we'll put 2 to the hydrogen as well. And let's give an example of a slightly more complex interaction. For example, if we take the substance sugar, C12, H12O11, then also by heating this substance can be decomposed to the element carbon, and next we have water. So we get carbon in the form of carbon black and water. Let's equate. Carbon on the left side is 12, here it is 1. So let's put 12 to carbon. But hydrogen, pay attention, hydrogen is 22 and oxygen is 11. Says that we should put 11 here. Let's check. 12 carbon on the right, 22 hydrogen, and here 22, oxygen 11, and here 11. A substitution reaction is an interaction between a simple substance and a complex substance, in which atoms of the simple substance replace one of the elements of the complex substance. For example, an interaction like this. Very often metals are involved in such reactions. For example, if we take zinc and hydrochloric acid, the zinc, because it's before hydrogen in the activity series of metals, it will displace the hydrogen and the result is zinc chloride. And the second gas is hydrogen. Let's equate. Zinc, we have equality of hydrogen 1. Here it is 2, so we will put 2 and check by chlorine. Here it's 2 and here it's 2. And this reaction cannot occur in the opposite direction. Now another example is potassium plus water. Potassium belongs to alkali metals, and when its reaction occurs, it reacts very violently with water, and the reaction leads to the formation of hydrogen, which can even catch fire. This reaction produces potassium OH potassium hydroxide and also hydrogen gas, which can even catch fire from the heat. Let's start equating. Here we need to start with hydrogen. The hydrogen on the left is 2, on the right is 3. It's the same technique we used in this case. Here it's even, on the right it's odd. Where it is odd, we will put the coefficient 2, respectively hydrogen on the right side became 4, and consequently on the left side we will put 2. Oxygen is 2, and on the right side 2, and potassium here is 1 and here is 2. This reaction will be equated. It's also irreversible. And it remains to find out what is a double substitution reaction or an exchange reaction. It's the interaction of two complex substances that exchange their constituents. And usually two complex substances are also released during the reaction. So here's an example. Let's say it's an interaction between a hydroxide base, sodium and sulfuric acid, H2SO4. And during the exchange reaction, and in exchange reactions it's convenient to use this kind of auxiliary frame for writing, then sodium and SO4 are combined. We can make this formula using the charges. So sodium plus SO4 has 2 minuses according to the rule of the SO4 cross. And the remaining hydrogen and oxygen in the frame give the right-hand side is water. Let's start equating. In doing so, we equalize the first elements that are behind the frames. Sodium on the left is 1, on the right is 2. 2 to sodium H, SO4 on the left 1 and on the right 1, hydrogen in total on the left 4, and here 2, so to water we put out a 2, and on oxygen check, here it is 2, yes 4 more, 6, and here it will also be 6. This reaction is called a double substitution reaction or an exchange reaction, and additionally it is called a neutralization reaction because between a base and an acid it is a neutralization reaction. But exchange reactions can also occur with the formation of other products. For example, if we take silver nitrate and potassium chloride, there can be an exchange reaction between these two substances, but it produces a precipitate argentum chloride, which we can show with this symbol, arrow down. If we do not sign the aggregate on the state of the substances, it is acceptable to write down arrow, which means that it is a precipitate. And the second one would be potassium NOI, potassium nitrate. Let's check argentum 1, chlorine 1, write 1, potassium 1 each, and no 3 also 1 each. This reaction will be irreversible, but this reaction is also an exchange reaction, only it is called a precipitation reaction, since argentum chlorine is a precipitate. So internally, this reaction can go both as a neutralization reaction and as a precipitation reaction. In addition to the basic types we mentioned today, there are additional classifications that we mentioned in the lesson today. For example, reversible and irreversible reactions. In addition, there are reactions that require heat to occur. They are called endothermic reactions, and there are reactions in which heat is released. They are called exothermic reactions. Part of the reaction can cause other reaction conditions, such as light. For example, photosynthesis, which requires light and is an endothermic reaction. There are other additional divisions of chemical reactions that we will definitely talk about in future lessons. Well, today, I hope these types of reactions are clear, you will not be confused about them, and will be easy to understand. That's all for today. Goodbye.